Hello, welcome back. This is lecture 2, Introduction to the R language and RStudio, and this is part 1. In part 1, we will cover the basics of the R language and RStudio, and in part 2, I will just show you how to just run and execute R commands directly using the RStudio program. So let's just start. Before I just move forward, so I would like to emphasize that if you are already familiar with both R and RStudio, so you can go ahead and open this script that I called the packages underscore to underscore install.r. This is an R script. So you can run all the codes in the script to install all the packages that we will be using in the rest of this course. So, and also after all the packages are installed, so one of these packages that we will use is I just named it as ADSUR. So those are the initials of our course name. Apply data science using R. So this package will give you a bunch of exercises to run and quizzes. So if you're already familiar with R and RStudio, so you can go ahead, install all the packages and run the library command to activate this package and begin with the exercises for lecture 2. Run underscore exercise is the function to activate the exercises for lecture 2. So, but if you're not familiar with R and RStudio, so this is going to be a good introduction. So we will cover the basics of the R programming language and also how to use RStudio to control R and run R commands. So why R and what is R and also like why R? So R is a free and open source programming language for statistical computing and data visualization. So R is cross-platform. So that means you can use R on Windows, Mac, or Linux, or any other operating system similar to these. So basically supported operating systems. So R is maintained and regularly updated by the comprehensive R archive network. So it is shortly called CRAN. So I shared the link over here if you want to go check it out. So R is capable of running all types of statistical analysis because there are a lot of R users, statisticians, mathematicians, data scientists. They all write functions, packages, so they share them through CRAN, and you can download them and use them whenever you want to use them. So R has amazing visualization capabilities, really high quality and customizable figures. So there are a lot of famous packages like Lattice, ggplot2. Those are really well-known packages for creating highly customizable, uh, high-quality figures. So R also allows you to create reproducible research. So that means, so whenever you keep your codes, your data set and everything else, you can keep track of what you did in your analysis. So if somebody has access to your data and your codes and also R, they can recreate all the outcomes and results that you have created. So R also provides many other features such as web programming. You can control Markdown, and there is something called R Markdown. So it allows you to run things inside R, like R codes, R outputs, and all the things could be easily transferred to a Markdown document, and that Markdown document could be potentially compiled as an HTML file, a web page, or any like a Word document or something like that. So, but we are not going to just focus too much on those features like web programming, but at least you should just know that R has those capabilities for sure. So a bunch of statistics about R. Right now, the current version of R as of this moment, as I'm just making this video, so it is 3.5.1, and R is constantly being updated. So you may be seeing a different version when you just watch this video. So that's okay. From each version, so they just the maintainers of R, developers of R, they are fixing certain bugs. They are adding new features, and they're just trying to make it more efficient and clear programming language. So right now, uh, there are almost 12,000, almost like 13,000 packages in the CRAN network. So like all these packages, some of them are base R packages, most of them are user created packages. So as long as you have R and you have access to internet, basically you have access to all of these packages available in the CRAN database. So there are also some useful functions like task views. So task views basically combine packages under certain titles, or let's say content groups. For example, like a machine learning task view, or there's a task view for psychometric analysis and things like that. So the task views allow you to just see a bunch of related packages under one category. Let's say you are interested in machine learning and you can see all related packages uh, uh, under that category. So basically, so here I just listed a bunch of resources for R. So the biggest one is the R project website. You can check it out. So there are free manuals again on the R website. So there are a lot of books related to R. Some of these books are open access. Some of them are just commercial books. So you can check them out using that link. R is also the R community is just running this annual conference, international conference called User. And so you may just check out presentations or new upcoming papers and presentations in the conference. Our bloggers is a really good website. There are a lot of experienced R users. They are just sharing their experiences and they just post examples of codes for creating different analysis, visualizations and things like that. Quick R is one of the websites that I frequently use whenever I just forget about a certain function or how to just set it up quickly. So I just go ahead and I check out Quick R. And finally, Cookbook for R is another useful website that I just always keep it in my bookmarks. So whenever I just need some examples or just to remind myself about the codes, I just go check those out because they are uh, the maintainers of these websites. They provided a lot of examples, useful examples for users. So what is RStudio? So when you just install R, so basically you will just see a screen like on the left hand side. So it's going to be a white screen like this. So that's called console. And you can also open a script and you can type your R codes in a script and then send them to the console. But basically this user interface, maybe it is useful, but at the same time it is not that useful because you cannot see the plots, codes and everything else in an efficient way. So RStudio takes care of that problem. So RStudio is a free software program available from the RStudio website. So you can download it and then you will notice that right away RStudio provides a much more like user-friendly interface for analysis and keeping your scripts, keeping your visualizations, everything else in one place. So I strongly recommend RStudio. So and we will be using RStudio in the rest of the lectures as well. So like I said, RStudio provides a user-friendly interface. It has also a couple of other features like syntax highlighting, so you will be able to see different colors for your functions, for objects you define in R and other components. So one feature that I really enjoy is the auto completion feature. So basically, as you type your codes and functions, so RStudio really helps you to complete your functions, and then basically just it keep. Let's say you are opening a parenthesis, it closes the parenthesis automatically. You are typing a function from a certain package, it after typing few letters, it auto completes, and then you just start typing the rest of it. So it is really helpful. And there are a lot of useful tools for easily saving figures and visualizations like histograms, scatter plots, or whatever you create. So you can resize the images easily and save them in whichever location you want. And also finally, So the workspace management in RStudio is really efficient. It really allows you to import and export data really easily, and also you can just see which data sets are active in your current R session. So all of those features are really easily accessible. So like I said, to benefit from these capabilities of RStudio, please install both R and RStudio at the same time, because again, RStudio relies on R, so it's not a standalone program, so you should have R and RStudio together in your computer. So when you open RStudio, you will just see a layout like this. So basically on the upper left hand side, so you will just see the console. On the right hand side, you will just see the source. So this is the area that we just type our codes and execute the commands and then send them to the console. On the bottom left corner, you will just see your files. You will just see your plots, the help files, and things like that. And on the right hand side, it is called the environment. You will just see whatever data is currently available active, or whatever functions are active in your session. So this part of the layout is also quite useful. So one good thing about this layout is that if you want to just switch those layouts, or as the R calls it, like those panels pretty much, so you can just shift them around. So you can just put your codes source on the top left corner, or bottom left corner, or just the other way around. You can always just move things around. So all those four windows, so they can be easily customized, and then just you can change their locations. So in R, so whenever we type codes in the console, basically once we close R, unless you save your workspace, so all the codes that you type will be gone. So to keep your codes and to be able to run the same codes again and again whenever you want it, so we typically create a script. So if you go to the file menu and a new file, if you choose R script, so that will create an R script for you. And then anything you type on the R script, and if you just save it, clicking on the save button right here, so you will just have access to that file anytime. So what this R script is actually a text file, even though the extension is like dot capital R. In essence, this is a text file, so you should be able to open this file either in R, RStudio, or even Microsoft Word, or Notepad, or any kind of like text editor. So like I said, once you create a new script, so then we can just type all of our commands in it, and whenever our codes are ready, so you can highlight the codes that you want to run, and then click on the run button right over here, and this run button will just send the highlighted codes to the console, and then you will just start seeing the results of your codes, as long as you there's no mistake in it. So if you want to just run the code line by line, you can bring your cursor at the beginning of your codes, and you can start clicking on run. So every time run function or run functionality will just skip the line, run line by line, and then it will go to the following lines one by one. So an important feature of R is working directory. So this is a useful feature, because working directory is a place that we just keep our files, data files, our scripts. Let's just say you are working on a project, so there's a folder that you keep all of your data files, codes, and everything else related to your analysis. So this is going to be your working directory. The good thing about working directory is that once you set up your working directory, you should be able to just call everything from that folder easily without specifying the full path. So otherwise, whenever you want to call or just import a data file or something like that into R directly, you will have to specify the full file path. But whenever you are running things inside your working directory, any file inside that folder, they are directly accessible. So, and we can just set the working directory in two ways basically. So You can either go to the session menu in RStudio and then click on set working directory and then finally choose directory. So this will open a window in your computer, so that will allow you to choose wherever whichever folder is your working directory. You can decide, you can show the path, and the R will just know that this is your working directory, and then the following analysis will accept it as your working directory. So the method that I use, the second method, is the one that I often use. I don't necessarily use the menu to choose my directory or set my working directory. I use the set wd command, so it is set working directory basically. So let's say I'm just setting up my desktop as my working directory. I keep my files on my desktop, so I just say set wd within the quotations. I just specify my file path. So one thing that I would like to emphasize over here is that we are using the front slash rather than backslash, because the backslash in R means that you are just using a command, or after a backslash a command will come. So basically, so you need to use front slash like this one to separate the lines. But when you just copy it directly from your computer, you will just realize that it is the other way around. So don't forget to just change these backslashes with front slashes like this. So then that way R will recognize it as a slash rather than a function or a command. So like I said, so R has a lot of packages, and we can install and activate these packages using install.packages command, and also we can use a library command to activate the packages. So let's say I would like to install a package, and DevTools and ggplot2 are the packages that we are going to use. If you use install.packages, so it will just directly connect to the CRAN database. So that means your computer has to have access to the internet. Otherwise, it's not going to work. So once we just say like install.packages, parentheses, and within the parentheses, like DevTools is the name of the package, and it has to be specified within the double quotes. So once we just execute this command, so basically R will contact with the CRAN database, call the latest version of the DevTools and ggplot2 packages, or either we can just run it line by line like this separately, or we can just use them in one line like install.packages, and I can put it inside a C or like a combine function. So C basically says I would like to install both ggplot2 and DevTools at the same time rather than separately. So it will just start with ggplot2. Once it is done, it will move to the DevTools package. So once both of the packages are installed, we can use the library command to activate these packages in the R session. So once we install the package, basically package is ours now, so you don't have to install it every time you open R. However, even though the packages are already installed, they are already in your R library. So whenever you need them, you need to call them into your R session using the library command. So if you just say library, parentheses, and inside double quotes, DevTools and ggplot2, those two lines will activate DevTools and ggplot2 packages in our R session. And from that point on, anything inside those packages, any functions from those packages will be available to us directly. So there's also another way of installing our packages. Sometimes some of our packages are not necessarily on the CRAN database. So there are a couple of other platforms. So like Bioconductor. So there's one platform. It's mostly for genetic analysis. So we are not going to focus on that one. And there's another function. This is called install_GitHub. So GitHub is a really nice platform for keeping R codes and basically any codes, any files. So it's a really nice platform for sharing files. If you're keeping some R files or R functions on GitHub, you should be able to install packages directly from GitHub rather than the CRAN database. So for example, the package that I created for this course, so it is accessible from GitHub, so it's in my GitHub account. So to be able to download that package, first we need to update the DevTools package. So because this install underscore GitHub comes from the DevTools package, so it's a function located in that package. So my username in GitHub is Okan Bulut, and a front slash and name of our package. So that will just connect to GitHub and install the package directly from GitHub. And again, just like we did before, we can use the library command to activate the package once it is installed correctly. And we can also just download packages as a zip file or like a compressed file. And if you have something like this, like a source file, then you can go to the tools option, click on install.packages, and using the browse menu over here, you can just show where that zip file is located, and then you can just install the package using that hard file basically. So basically that file is going to be located in your computer rather than accessing internet. So you are downloading the package directly from that folder or from that zip file. So, but again, the first two methodologies are the more common ones because some packages, almost all packages have dependencies. So just downloading one package may not be good enough to be able to set it up properly, because you may, let's say I downloaded the zip file for ggplot2, but if ggplot2 requires other packages and dependencies, and if I don't have internet access, so basically ggplot2 installation will not work. So of course we will do a lot of analysis in this class. However, R also could be easily used like a simple calculator. So you can just add up numbers, subtract them, multiply them, divide numbers. You can do combinations of those operations. You can basically simply add things up, multiply them, divide them, and within the same line, just like you are using a regular calculator. So you can also do other things like taking the square of your values, square root, the log, exponential, cosine, and things like that. So all of those features, like mathematical features, are available in R. So in R, in order to create a new variable, we need to use the assignment operator. So this looks like an arrow sign, and sometimes you will just see that people are using the equal sign. But I strongly recommend using the assignment operator, this arrow sign, because it gives you a clean look in your codes, and it's also easily distinguishable in your codes rather than the equal sign. So let's say I would like to create a variable called x, and x equals to 1. I just say x, and I put my assignment operator, and I just say 1. From that point on, whenever I type x equals to 1 now inside the session. So if I type x in the console and then just click hit, or if I just put x in my script and highlight it and run it and send it to the R console, and then R will print 1 because that's the number that we assign. So we can also assign multiple values to a single variable. For example, let's say I would like to define a variable called weight. So in this case, I'm using the C command to combine several values within under the same variable. So let's say I'm defining a weight variable. Weight is 60, 72, 80, 84, and 56. And every time I just use the comma to separate those values. And from that point on, whenever I execute this, so weight will give me those 5 numbers. And same thing for height. So you can just define numbers with decimal points too, so they don't have to be just integers. Some basic functions in R. So basically, once we define a variable in R, so we can just do like further calculations with it. So let's say I define weight as kilogram, but I would like to just transform those to pounds. So I just multiply all the weights in the weight variable that we just defined earlier and multiply them with 2.20462. So, and I define it as a new variable which is called weight2. So that way I don't override my existing weight variable. I create a new variable, and weight2, when you just print it, it will just give you the adjusted values, weights as pounds. So, and like I said, we can also just define a new variable based on the existing variables. So let's just say we just define a reading variable, we define a math variable. Those are, let's say, test scores. And if I want to create a total test score, I can add them up. But at this point, just realize that they have the same number of values in them. So reading has 5 values, math has 5 values. When I add them up, R knows that they have, both of them have 5. It matches them one by one. So at the end we get the total scores, and I save it as a total score, and then we get the total scores like 170, 140, and then it goes like this. So we don't necessarily have to create quantitative variables. We can also create qualitative variables like text. So like some categories. So for example, I would like to define a new variable called cities. Cities hold a bunch of values: Edmonton, Calgary, Red Deer, Spruce Grove. So I can type them one by one. Only difference is that if you are typing a text, a qualitative variable like this, you need to use quotations. Otherwise, R will assume that that's a variable name rather than a value. But in this case, Edmonton, Calgary, Red Deer, Spruce Grove, they are just values, or they are just elements of the variable called cities. So I can define cities whenever I type cities. So cities will print out those 4 cities that I defined in it. So in the same way, so let's say we would like to define a gender variable, and I would like to use numbers, but I don't want those numbers to be considered as numbers. I want them to be a kind of like a numerical label. So let's say 1 is female, 2 is male. So I can define them as like this way, 1 and 2. So that way R knows that this 1, 2, 2, 1, 2. So these values are not necessarily numbers. So these are just labels. So they represent something else rather than numerical values as 1 and 2. So a bunch of rules, and those are the useful rules to know for sure. So first thing is that R is case sensitive. So that means whenever you write codes in lowercase, if you just try to write the same thing in uppercase, it's not going to work. So if you define something in uppercase, and if you try to call the same function or package or object or whatever that is, it's not going to work. So in this example for here, I just said cities: Edmonton, Calgary, Red Deer, Spruce Grove, and they're all lowercase in cities. And if I type cities with only using the uppercase C, or cities as like all uppercase letters, and every time R will just tell you that, hey, you don't have cities, so they do not exist, even though they are still the same thing, like cities, 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 but R only recognizes the cities as you defined it in the first line in lowercase. So that's pretty much it. So some rules about variable names. So a variable name cannot begin with a number. So that's one rule in R. So you cannot create a variable, let's say 1 city or something like this, or 2 cities or something like that. So 2 cannot be a number and at the beginning of a variable name. And a variable name cannot include a space. So let's say I would like to call a variable, I would like to create a variable, and I would like to call it my cities. R will just say that there's an unexpected symbol in my cities, which is the space. So if I just delete the space, and I call it like my cities without any space in it, that would work. But whenever I include a space between 2 words, R will just recognize the space as a character, so it will just give you this warning that you are having an unexpected symbol. Some naming conventions. So as you just learn R, as you use R, you would realize that it is good to have some conventions. It is good to have your personal rules about how to name variables. So for example, when you just create new variables, you can always use lowercase just to be consistent in your code, or you can just separate multiple words by dot. So let's say my cities is going to be my dot cities, or you can use underscore, which I also appreciate because underscore gives a really clean look. So let's say I would like to create a variable called my cities. So I just define it as my underscore cities. So that's going to be the variable name. So, or you can put some numbers at the end. So sometimes I do this, but the negative side of this approach is that sometimes we forget which numbers we use. We just create a data set, call it like data 1, data 2, data 3, and then we forget which data was created and when. So, and that's why it is good to have some naming conventions so that you can, when you take a look at the data, you know what that data really uh, has, what it includes. So that's why it is really important to keep the naming conventions, naming rules really consistent. So whatever you decide at the end, I strongly recommend you to use it consistently and all the time the same rules, so you don't get confused by your own codes as you just try to rerun them later on in the future. Commenting on R happens with hashtags. So whenever you just type hashtag and anything that comes after hashtag becomes a comment, like comment in R. So basically, so in this example, I just say that here I define 4 cities in Alberta. So since I just started with hashtag, here I define 4 cities in Alberta becomes a comment. So basically that command is good because we can create annotations like this to remind ourselves what we did and why we created that variable and how we manipulated it and things like that. It is also helpful because whenever you would like to deactivate some code or remove it from your function or something like that, but you don't want to delete the line in case you may need it in the future. So if you put a hashtag at the beginning of that line, so for example at the bottom of the slide, I just say cities, Edmonton, Calgary, Red Deer, Spruce Grove. Since I added the hashtag, from that point on, my cities, that cities variable would be a command. So that wouldn't define cities. So in order to define cities as a variable, I need to delete the hashtag line and just make it active again as an R command.